Class example 2.41 shows some of the more common problems we see in the polynomials chapter. Here we'll work with graph to determine the multiplicity of zeros and write the equation of a function. Now we're told that the graphs below correspond to polynomial functions for which the leading coefficient is either 1 or negative 1. So there may have been a reflection in the x-axis, but there has been no vertical stretch. We're also told that the zeros are integer, so no decimals or fractions. We're asked to determine an equation in factored form and of minimum degree for each function. Well, factored form means the question is being nice to us. We don't have to do any work to develop it out. But what does it mean to say minimum degree? Well, remember, we are unable to discern with our eye whether the multiplicity of a zero is 2, 4, 6, or 8, or 3, 5, 7, or 9. We can only tell that it is odd or even. By saying that it is of minimum degree, that means we will treat all x-intercepts that bounce as though the degree is 2. And we'll treat all x-intercepts that squiggle through with a point of inflection as being of degree 3. Again, it's possible that they are 5 or 7 or 9, but we're not able to tell this with only our eye. Let's look at example A. Here our polynomial has 3 distinct x-intercepts, -2, 0, and +3. Each one will generate a factor in our polynomial function. Note, when the intercept is -2, the factor is x plus 2. When the intercept is +3, it's x minus 3. And when the intercept is 0, it's simply x. There's no need to write x plus 0 or x minus 0. Because our graph passes through at -2 and 0, we know that their multiplicity is only 1. However, because it bounces at +3, we know the multiplicity is even. And because we're working with a minimum degree, we'll say that it is 2. This means our polynomial function can be written as x times x plus 2 times x minus 3 squared. The lead coefficient will be positive. This is because the right arm ends up in quadrant 1. Let's try our second example. Here, we have x-intercepts at -2, +1, and +3. Note that the intercepts at +1 and +3 pass through the x-axis, but at -2, we have a point of inflection. The x-intercept of -2 corresponds to the factor of x plus 2, and because of this squiggle, we know that it is an odd degree greater than 1, so it is at least 3. And because we're working with a question of minimum degree, we will say it is 3. Here, because the graph ends negative in quadrant 4, we know the leading coefficient is negative. In later examples, we will do similar problems where we assume there could be a vertical stretch. So instead of writing a 1 or -1, we'll introduce a value of a. But for now, we simply need to know whether the graph was ending up or ending down.